Welcome to the second part of my final project presentation. In this part, I'm going to demo my system for this project. First of all, for just reminding again, the name of my project is an evaluation of performance of transformers and traditional machine learning models for binary text classification. And the goal for my project was to evaluate performance of three transformer models, BERT based on case, distilled BERT on case, and generative pre-trained transformer, also known as GPT-2. I also compared these transformers or deep learning methods result with a traditional machine learning method, SVC, support vector classification, which I showed them in my write-up report. Okay, let's get to this. As you can see, I'm using Google Colab. Why? Because for deep learning experiments, it's so hard to use my own laptop, so I use this interactive Python programming environment here. This is an excellent tool for deep learning tasks, which gives me free access to Google computing resources such as GPUs and TPUs. Let's get started here. Here I'm going to, for this part I'm going to run the BERT base code here, and then I go through the other one, which is the distilled BERT and GPT-2 part. They all take a lot of time. So for the sake of the presentation, I'm just using 100 posts. Let's just get through this. So just install transformers. Pandas is coming to help. Now let's load the pre-trained BERT model here. Here we are going to import a data set. I will use Panda to read and load data frame. As you can see, I have 3,000 posts from drugs.com and WebMD, which I collected. It uses 2400 for pre-training. And then we are going to prepare the data set. Before we can hand our sentences to BERT, we need to do some minimal processing to put them in the format it requires, which is tokenization. Our first step is to tokenize the sentences, break them up into word and subwords in the format BERT is comfortable with. And as I said, for the sake of the presentation, I'm just using 100 posts here. Sorry about that. Tokenizing them. Now we're getting to the padding part. For the padding, after we tokenize, each sentence is represented as a list of tokens. We want BERT to process our examples all at once. It's just faster that way. For that reason, we need to pad all lists to the same size, so we can represent the input as one 2D array rather than a list of lists. So, masking part, if we directly send padded to BERT, that would slightly confuse it. We need to create another variable to tell it to ignore mask the padding we've added when it's processing its input. That's what attention mask is about. Now let's get to the interesting part, which is deep learning. The input is ready, and now we are ready to run our model. This is the main part. The main analysis happen here. The model function runs our sentences through BERT, The result of the processing will be returned into last hidden states. It takes a while. I'm just using 100 posts. Honestly, for all my posts for BERT base, it takes about 25 minutes, and for GPT-2, it takes exactly 1 hour and 47 minutes, I think, around almost 2 hours. I'm not going to run GPT-2 here. Okay, it's done, this part. Our dataset is now in the padded variable. We can view its dimensions below, which is here, 100, 128, 768. And let's get to features here. That is the output corresponding to the first token of each sentence. The way BERT does sentence classification is that it adds a token called CLS for classification at the beginning of every sentence. This is interesting. The output corresponding to that token can be thought of as an embedding for the entire sentence. We'll save those in the features variable, as they'll serve as the features to our logistic regression model. Now we're getting to the train/test split. Let's now split our dataset into a training set and testing set. Let me run it. And here is the logistic part, logistic regression. Now we now train the logistic regression model. If you have chosen to do the grid search, you can plug the value of C into the model declarations. And evaluating the model, I use scikit-learn for the evaluation part. So how well does our model do in classifying sentences? One way is to check the accuracy against the testing data set. So as you can see, for 100 posts, we have the accuracy of 96%, 100% recall, F-score 98, and precision 48. The real result that I got for all my posts is in my write-up. The table is in my write-up report, also in the slides that I have. Here is the DistillBERT part, which is pretty similar. There's maybe one or two line of the code is different. It's like very similar, I would say. And this is the GPT-2, which it takes a long time, around